Okay, in this video, we're going to be working in section 3.3 using systems of equations to solve word problems. And we're going to be using these steps in order to solve the word problems. First thing that we're going to do is define our variables. Then we're going to set up the equations, put the equations in standard form, set up a matrix and enter it into the calculator, and then be sure that we answer the question that was asked. Okay, problem 1. A baseball team played 21 games. They won 3 more than they lost. How many games did they win? How many games did they lose? Well, the first thing that I want you to notice here is that we're asked 2 different things. How many games the team won and how many they lost. Those are the 2 unknowns, so those are going to be what my 2 variables are going to represent. Now, before I write my equation, I want to kind of organize my thinking. And in kind of a broad terms here, what you need to understand is that you've got games that are being won and games that are being lost. And when you add those together, you get the total amount of games. Now we're going to assume that there's no ties. So here's a representation of what we have going on with this problem. Okay, so I have the number of wins plus the number of losses equals the total number of games. Now, the number of wins is W, and I'm going to say that the number of losses is L, and I know that the total number of games is 21. So there's my first equation. Now let's go back to this second sentence. They won 3 more than they lost. We're going to use that sentence to come up with my second equation. Since they won 3 more than they lost, that means that if I took the number of games that they lost and I added 3 to that, then I would get the total number of wins. So that's my second equation. So now I have my 2 equations. I need to take these 2 equations and be sure that they are in standard form. Notice that over here I have W for the first letter in the first equation, and I have L for the first variable in my second equation, and we need to be sure that we have the same variable being first in both. Okay, so I've taken this second equation and rearranged it. So now my 2 equations both have the W's first, then the L's, then the equals, and then the constants. So I'm going to take the coefficients from those 2 equations and set up my matrix. Okay, we're going to put that matrix into the calculator, and this is what I get out. So what I have here is W equals 12 and L equals 9. So that means there are 12 wins and 9 losses. Okay, problem number 2. A soccer field in Kirksville has a perimeter of 320 yards. Its length measures 40 yards more than its width. What are the dimensions of this field? Well, the first thing I'm going to do is to make a quick sketch. Okay, and W is going to stand for the width and L is going to stand for the length. I don't really need to write that out. My first sentence says that a soccer field has a perimeter of 320 yards. So I know that I'm dealing with the perimeter formula. And there's a couple different formulas that I can use, but we're going to use this one. Perimeter equals 2L plus 2W. But I know that the perimeter is 320, so I can go ahead and replace this P with 320. So I get 320 equals 2L plus 2W. Now my second sentence says its length measures 40 yards more than its width. So that leads me to the equation width plus 40 equals L. So these are my 2 equations that I'm going to use to set up my system. I'm going to rearrange these 2 equations so they can be in standard form. Now you may have rearranged your equations differently, but you're still going to get the same answer in the end. So from here, I'm going to set up my matrix and then put my matrix in the calculator. Now remember that the numbers in this first column are the coefficients of the L terms. So that means that L is 100. And this second column has the coefficients of the W terms. So that means that W is 60. So my length is 100 yards and my width is 60 yards. Okay, problem 3. 3 adult tickets and 2 child tickets to the fair cost $28. 2 adult tickets and 4 child tickets cost $32. Determine the cost of 1 adult ticket. Determine the cost of 1 child ticket. So the first thing I need to do is to identify my variables. Okay, now the next thing I want to do is to sort of get a big picture overview of what's going on. I have the cost of the adult tickets and the cost of the child tickets, and then together I know their total cost. Okay, so there's the boxes. It's going to sort of organize my thinking and help me get my equations. All right, the first sentence says that 3 adult tickets and 2 child tickets cost $28. So 3 adults and 2 child tickets are going to cost $28. My second sentence says 2 adults and 4 child tickets cost $32. So those are the 2 equations that I'm going to use to set up my matrix. Okay, so I put that matrix into my calculator and solve. Okay, and again, this first column contains the coefficients of the A terms. So A is going to be 6. This second column contains the coefficient of the C terms. So my C is going to be 5. So the adult tickets are going to cost $6 and the child tickets are going to cost $5. Okay, problem 4. Tickets to a high school play cost $5 for adults and $3 for students. If 184 people attended and $812 was collected, how many of each type of tickets were sold? So I want to know how many adult tickets were sold and how many student tickets were sold. Those are my 2 unknowns, so that's going to help me identify my variables. So A is the number of adult tickets and S is the number of student tickets. Now in my first sentence, it tells me how much each ticket cost, and I know the total amount of money that was collected. I also know the total amount of people that attended the play. So I'm going to write one equation based on the number of people, and I'm going to write a second equation based on the cost. Okay, so my first equation is based on this information. I have the number of adult tickets, the number of student tickets, and altogether there's the total of 184 tickets. So A plus S equals 184. Now my second equation is going to be based on the money that is collected from each of these 2 types of tickets. I know that if I take the money that's collected from the adult ticket sales and the money that's collected from the student ticket sales and add them together, I get the total amount of money that was collected. Okay, so let's look at how I'm going to get this expression for the adult tickets. Well, I know that the adult tickets were $5 a piece. If there were 10 tickets sold, I can multiply 5 times 10 to get the total amount of money collected from the adult ticket sales. If there were 100 tickets sold, I'd multiply 5 times 100. Right, so what I have here is A tickets sold, so the amount of money collected is 5A. Similar thing for student tickets. Student tickets were $3 a piece, so 3 times the number of student tickets is going to give me the amount of money from those sales. And then I know that altogether there was $812 brought in. Okay, there are my 2 equations. Now I'm going to set up a matrix. I'm going to go ahead and solve that matrix. So I get A to be 130, S is 54. So there's 130 adult tickets sold and 54 student tickets sold. Okay, problem number 5. Sandy wants to mix tea that is worth $8 per pound with tea that is worth $4 per pound to obtain an 80-pound mixture worth $5 per pound. How much of each type of tea should she use? Okay, so let's think about what we're asked to find. I want to know how much of each type of tea should she use. So my variables are going to represent the amount of each of those two types. Okay, if you look at the big picture of what's going on here, I've got some expensive tea and some cheaper tea, and we're going to mix that together to get sort of a medium priced tea. Okay, I have 2 units of measurements in this problem. I'm measuring cost per pound, which is going to be measured in dollars, and then I'm also measuring the weight of the mixture, which I'm measuring in pounds. So I'm going to make 2 equations. One is going to be based on the amount of the tea in pounds, and my second equation is going to be based on cost. Okay, so the number of pounds of the $8 tea, I'm going to let be X. The number of pounds of the $4 tea is going to be Y, and I know that when I add those together, I get 80 pounds. Now my second equation is going to be based on the cost. So I have expensive tea and cheaper tea. Mixing that together is going to get me some medium priced tea. Okay, so the cost of the $8 tea plus the cost of the $4 tea equals the total cost. And the cost of the $8 tea is going to be 8 times X. The cost of the $4 tea is going to be 4 times Y. And the total cost, this is where students would mess up. If they're going to mess up, this is where they would mess up. The total cost is going to be 5 times 80. It's not just 5, it's $5 per pound, and there's 80 pounds. What I want you to notice is that this first equation has the X, the Y, and the 80. For my second equation, I'm going to use X and Y and 80. The numbers that are up front of those highlighted parts are the $8 per pound, $4 per pound, and $5 per pound. Right, so each of those costs are multiplied by pounds. So now let's rewrite our 2 equations. Now I'm going to go ahead and multiply out this 5 times 80 and get 400. So there are my 2 equations. So I'm going to set up my matrix. I'm going to put that matrix into my calculator and solve. Hey, now on this problem, it's especially important that you remember what you let be X. Now before we've had like A for adult tickets or L for length. It was kind of obvious, but here I just have X and Y. So you have to remember that this first column is representing the X, and X is representing the amount of the $8 tea. The Y is representing the amount of the $4 tea. So X is 20 and Y is 60. So I have 20 pounds of the $8 tea and 60 pounds of the $4 tea. Now one thing I want to point out is that on the homework you may be asked to find the more expensive tea or the cheaper tea. So pay attention to what you're asked to find. Okay, problem number 6. How many ounces of 5% hydrochloric acid and 20% hydrochloric acid must be combined to obtain 10 ounces of solution that is 12.5% hydrochloric acid? Okay, to kind of get an idea of what's going on here, I want to look at sort of a generic situation instead of the particular numbers in this problem. Okay, so let's look at these 2 beakers. The blue lines represent the fill line, or how much solution there is. And let's say this green stuff is representing the hydrochloric acid. I'm going to combine what's in these 2 beakers, and I'm going to end up with something that looks like this. All right, in my first beaker here, let's say that this beaker contains a total of 15 ounces of solution. The second beaker is going to contain a total of 20 ounces of solution. So that means over here I've got a total of 35 ounces of solution. Now let's say in my first beaker I have 3 ounces of the green stuff, and in my second beaker I have 6 ounces of the green stuff. Then that means all totaled I have 9 ounces of the green stuff. So I've got one equation up here, 15 plus 20 equals 35. That's based on the total amount of stuff. And I have a second equation, 3 plus 6 equals 9, and that's based on the amount of the green stuff. So what we're going to be doing with our problem is we're going to be using this same type of thing. We're going to write an equation that's based on the total amount of solution, and we're going to write an equation based on this stuff that's in the solution, in our case, hydrochloric acid. Okay, there's a description of the first situation I have going on. The amount of ounces of the 5% solution, we're adding that to the number of ounces of the 20% solution, and all totaled, we're going to end up with 10 ounces. So there's my first equation. Now my second equation is going to be based on the amount of hydrochloric acid. That's comparable to the green stuff that's in this picture. Okay, the amount of hydrochloric acid that's in the 5% solution is going to be 0.05 times X. The amount of hydrochloric acid in the 20% solution is 0.20 times Y, and the total amount of hydrochloric acid is going to be 0.125 times 10. And now what I want you to notice here is that in my first equation, I have X, Y, and 10. And in the second equation, I have an X, a Y, and a 10. And all of the numbers that's up front of those yellow things that are highlighted is the percent. 5%, 20%, 12.5%. So this will give me my two equations. So these two equations lead to my matrix. Okay, one thing I want to point out to you when you enter your matrix is that this last cell here, I can just put this in as 0.125 times 10. I don't have to multiply it out before I put it in. Your calculator can handle this for you. Go ahead and press enter, and you can see that the number there ends up being 1.25. So there's my matrix. You solve the matrix and you get this. So I end up needing 5 ounces of the 5% solution and 5 ounces of the 20% solution. Problem number 7, Phil invested $5,400 in 2 different accounts. One account had a return of 11% and the other account had a return of 9%. And last year, Phil earned $546 in interest. How much was invested at each rate? Right? So we have money in one account and money in a second account, and I know that all totaled, we have $5,400 in those 2 accounts. Okay, so there's a description of what I have going on. I'm going to let X be the amount of money invested at 11%. Y is going to be the amount of money invested at 9%, and I know that all total there's $5,400. Now my second equation is going to be based on the amount of interest that I'm earning from each account. Okay, the interest earned from the 11% account is going to be 11% times X. The amount earned from the second account is going to be 0.09 times Y. And I know that the total amount of interest earned is $546. So those are my 2 equations, so I can set up my matrix and solve. Okay, so we end up with $3,000 that was invested at 11% interest and $2,400 that was invested at 9% interest. Okay, problem number 8. A wholesaler supplies college T-shirts to 3 college bookstores, A, B, and C. And the wholesaler recently shipped a total of 800 T-shirts to 3 bookstores. Twice as many T-shirts were shipped to bookstore B as to bookstore A, and the number shipped to bookstore C was 40 less than the sum of the number shipped to the other 2 bookstores. How many T-shirts were shipped to each store? So I'm not going to write out what my variables are going to be. Obviously, A is going to be representing the number of T-shirts that were shipped to store A. B is going to be the number of T-shirts shipped to store B, and so on. So I know that all totaled, there were 800 shirts. Okay, so there's my first equation. Now let's go to this sentence right here. Twice as many T-shirts were shipped to bookstore B as to bookstore A. So that means if I took the number of T-shirts that were shipped to store A and multiplied it by 2, then I would get the number that was shipped to store B. Right? Twice as many were shipped to store B. So 2 times A is going to equal B. Now let's look at the second part of this sentence. The number shipped to C was 40 less than the sum of the numbers shipped to the other bookstores. Okay. The number shipped to store C was or is means equals. Okay, 40 less than, that means I'm subtracting 40 from something, and I'm subtracting it from a sum. So sum is the answer to an addition problem. So I have to be sure that I get that answer and then subtract the 40. Well, the sum of what? The sum of the other 2 stores. So the sum of A and B. So those are my 3 equations. I need to rearrange them so they're all in standard form. Now you may have arranged these a little bit different, so you have negatives where I have positives, but that's okay. Those are my 3 equations, so I can set up my matrix. Put that matrix into my calculator. Okay, so there's my answer. Now, ran out of room to actually write my answer over here in full sentence, but store A is going to get 140 T-shirts, store B is going to get 280, and store C 380. And one thing I want to mention I forgot to earlier is that there's more than one way to set up these problems. It doesn't matter to me which way you do these problems as long as you are able to write a system of equations and solve.